Hi all. In my previous video, I have explained the series voltage regulator with a controlled transistor without emitter follower and with a negative feedback also. But there wasn't any sort of protection available, and that is explained in this video. This is the circuit for control transistor with over voltage, overload or short circuit protection, and this Q3 and R5 provides that protection. Now why do we need this? If in case there is a reduction in RL suddenly, or if the load terminals are accidentally shorted, what happens is like a very large amount of current flows through the load, and that might entire circuit also, and that might destroy our QN and diodes and also other components in the circuit. And so in order to protect the entire circuit for due to this short circuit or reduction, a sudden reduction, high drastic reduction in RL, we need to include this protective elements like Q3 and R5. And fuse can also be provided, but fuse will not be protecting the transistor, because the transistor gets damaged within the fraction of seconds. So in order to avoid this, the current limiting circuit is added, which is this Q5 Q3 and R5 connected to the base of this Q1. Now, to understand the circuit in a much better way, we'll assume few cases. Under normal working condition, the circuit will be operating like the one as I explained in my previous video. In other words, Q3 will not be on, and these two elements will not come into role, which means R5 will be there, but there won't be any conduction of Q3 during the normal working condition. So this is the normal case with normal load current. But if in case there is any excessive load current flowing through that, for an example, if it is more than 600 milliamps or more than 700 milliamps, and obviously a voltage drop across the R5 will be sufficient enough to make the Q3 to conduct, as because the base of the Q3 is connected to the R5. So voltage drop across the R5 will be available across the base of Q3, which will make my Q3 to work right now. And this happens during the excessive load current. Once Q3 is on, IC3, this flows through the R3, and obviously because of which IB1 decreases, or the base current to the Q1 will be decreasing. This results in the conduction of Q1, no, reduction in the conduction of Q1, and therefore the increase in the IL is now prevented. So this is how the protection is provided by means of having or adding the Q3. And there can be another case also when RL is infinite, which means the resistance across the load is infinite. Now, voltage V out is always regulated output voltage, and so IL becomes zero for this condition, operating condition. And so when RL starts decreasing, IL starts increasing up to a point where RL becomes equal to the RL minimum. Now at RL minimum, IL will be equivalent to, as I mentioned earlier, it will be approximately equal to 600 milliamps, and VBE voltage will be zero point 0.6 volts. Now beyond this range, Q3 turns on and the current limiting sets in. And further decrease in the RL will tend to decrease in the output voltage, which will affect the regulation, which means the regulation will be lost. So when RL equal to 0, then IL will be limited to a value of 600 milliamps to 700 milliamps. Now we have to check the short circuit, no, shorted load terminals current, which means the load current at the load terminals, that we call it as ISL for this condition. And so ISL will be nothing but it will be around equation of VBE by R5, and so VBE will be zero point 0.5 to zero point 0.6 to zero point 0.7 volt. So the minimum load resistance RL minimum is nothing but where the regulation is lost can be calculated by RL minimum equivalent to V regulation by ISL. In other words, I can say that RL minimum is the minimum amount of resistance that has to be maintained in order to maintain the regulation. and it might be RL minimum might be less, slightly less or greater than this particular old value, no, V regulation by ISL. The only thing is drawback in the circuit is large power dissipation across the series pass transistor, and this can be overcome by putting the heatsink.